Hello everyone. In this video, I'm going to be explaining to you the working of this particular relay over here. And in this, we'll be taking the application of a simple street light in which we will be having this particular photoresistor or the LDR over here, which will be showing us whether it is day or night. And similarly, this PIR motion sensor over here will be telling us whether a person is moving there or not. So this light bulb is going to go on only during the night time, and this PIR motion sensor will only work at that particular time in turning this on or turning this off. This is how we are going to program this over here, and for this we are going to be using a AC bulb over here, which is going to be the bulb over here, which is going to be working as the street lamp over here. So for controlling this, we will be having this particular relay component over here. So we'll be looking into this into detail. I hope you got an outline on what we are going to see. So we're using the Arduino microcontroller to controlling the turning on and turning off of this particular lamp over here. And this will happen only during the night time. So we are going to make sure that the LDR sensor is positioned accordingly. During the daytime, even if there is motion sensed by this PIR motion sensor, there will not be any change in this turning on or turning off of this particular lamp over here. So before we go into the coding part, I will just give you a small demo on how this is working over here. So we can see that I have put it into nighttime over here, the LDR sensor. If I move it to daytime, that is equivalent to the sun, and now it is a nighttime over here. And now what I'm going to do is I'm going to make sure that the PIR motion sensor there is movement. So I click on it, and when I drag it, you can see that the lamp is on over here. This lamp will be on for 5 seconds, then it will go off back again. Okay. So when there is movement, this will be continuously on for 5 seconds over there. When movement stops, what will happen? It will be on for that 5 seconds, and after that 5 seconds, it will turn off over here. And similarly, instead of night, when it is day, as I told you earlier, but what is going to happen over here? Even if there is movement over here, what will happen? The lamp is not going to go on. So this is just like a prototype of a street light. Okay. So during daytime, any motion, light doesn't have to go on. Street lights will never go on at that time. But beyond particular value, when it is equivalent to night over here, you can see that when it is fully dark, at that particular time, the particular lamp goes on when there is motion sensed by this PIR motion sensor. So this value has to be specified in my program over here. And during what particular value, this particular time is day and what particular time it is night over here. And this is the connection we will look into for now before we go into the program. So this is my Arduino board over here. All these components are available on the right side menu, and you have to make sure that you click the components and click all over here. So you'll be able to get that. So I took the Arduino from this part over here. I took the resistor from here and I placed it over here, and the resistor I've kept as 10 kilo ohm. And similarly, I have my photoresistor over here. The photoresistor can also be taken from here. The 9-volt battery was taken from this particular position over here. And similarly, I have a photoresistor which I have taken from here. I have a PIR sensor which was taken from this particular place, and I have an incandescent lamp also, and I have my lamp right over here. Light bulb. I have my light bulb over here, and I also took my relay, the last component that is required for now, and that particular relay was taken from relay SPDT. Okay, so that is what is over here. So these are the components that are required in building this particular circuit over here. Now we will look into how the circuit was connected. Then we look into the program. That will give us a clearer picture over here. So first we will look into this particular relay part over here. If you connect this 9-volt battery direct to the bulb over here, what will happen? The bulb will always be on. You cannot control the on and off over here when you connect it directly. So if you want to control it by program, that is where you will be using this component which is called as a particular relay. In here you will be having a particular switching principle over here such that this particular input, when it is 1, there is a short circuit between this particular positive terminal of the bulb and the positive terminal of the particular battery. So as of now you can see that there is a separate red color wire over here and a separate red color wire over here. And when this value is 1 over here, these two wires get shorted to each other. So it means that the bulb is going to glow. And when this particular value over here is equal to 0, this particular connection is switched off or disconnected. That is when this particular light goes off over here. That is how this relay is helping us in controlling a particular bulb over here. And as you may see that this is a bulb working on 9 volt, and you may know that an Arduino can work only on a maximum of 5 volts. So it can work only on 3.3 and 5 volts over here. If you want to go beyond 5 volts, you cannot connect a bulb directly to this Arduino over here, and that is when you will be using a 9-volt battery. And for that controlling purpose, when 9 volt is to be controlled, 9 volt bulb is to be controlled, you cannot control it directly using an Arduino, and that is when you will be using this relay over here. So there are totally 4 connections required in this relay over here. One of the pin that is connected to Arduino, that is pin number 13. You can remember that in your particular code that pin number 13 is connected to relay over here. Then you have your particular bulb over here connected to one of the positive terminal over here, and the other end of that is connected to this 9-volt battery over here. The negative end of this battery is connected to the negative terminal of the bulb over here, and this negative end of the relay is connected to the negative end of the Arduino over here. So this makes it a particular loop when 13 is equal. Pin number 13 value is put to 1 over here. So this is how this particular relay is going to work. So I hope you're able to understand that for now. So next we are going to look into the component which is the LDR sensor or the photoresistor. So when light falls on it, it is going to do a particular thing. When light is not falling, it is going to do a particular thing over here. So this works on the principle of luminescence. Okay, so when light is falling on it, it becomes a good conductor over here, and when light is not falling on it, it becomes an insulator. So this is a resistor over here, LDR, light dependent resistor. So when light is falling on it, the resistance value becomes very less and it is a good conductor. And when light is not falling on it, resistance is very high and it becomes an insulator over there. So based on this principle, you're going to use this LDR over here. So that is how you're going to be connecting it to this particular Arduino board over here. So one end is connected to the positive 5 volt supply over here. The other end is connected through this resistor to the ground over here. And from that also you'll be having one end connected to the analog pin over here. As the readings over here are going to be analog in nature, you're going to connect it to the analog pin of your particular Arduino. You're not going to get a 0 or a 1 only. You're going to get many values from this LDR. So you're going to connect it to the A0 pin. And that is what you see over here. It is connected to the A0 pin over here. That is being declared over here. So next I have one more component that is used in this particular circuit called the PIR sensor. So this PIR sensor has 3 pins, in which one pin is going to get the output and it is fed to pin number 2 over here. And that you can see in this particular program that input of PIR is given to pin number 2. So that I have declared in my program. The other end is connected to the power supply, that is the 5 volt over here, and the other negative terminal is connected to the ground over here. So the PIR sensor, as you know, it detects motion. So in this PIR sensor, I'm not going to get the X, Y, Z value. So I'm not going to connect it to the Z terminal, to the analog pin. I'm just going to detect whether there is motion or not. Okay, so to detect whether there is motion or not, two values only, motion or not. So I'm going to connect it directly to the digital pin rather than connecting it to the analog pin of it. Okay, so this is the connection that is being taken care in this particular circuit over here. Next, I will be going into the coding part. So the coding part depends on what I am going to provide. So as I told you, I have given you the explanation of the circuit working over here. So relay is connected to pin number 13. The input PIR is connected to pin number 2 over here, and the particular sensor LDR is connected to pin number A0 over here. Similarly, the value that I am reading from this particular PIR sensor has to be stored in a variable, and that variable I'm going to call it as PIR val. Okay, so PIR val, I'm initializing it to value 0 here. And similarly, the value of my LDR sensor, the LDR sensor also needs to be stored in a variable, and that variable is what I'm going to give by this particular name, resolve sensor LDR. Okay, so all the declaration parts are to be given before the particular void setup. That is the Arduino programming principle. Okay, so all the declaration, or if there's any additional library file required, everything should be provided before the void setup. Next, I'm coming into my void setup over here. these lines is where you will be declaring your input and output ports. And if you're using a serial monitor, you'll be using the serial begin also. These lines get executed only one time. So you see that your relay is a particular having a particular output over here. From my pin number 13, I am giving a 1 or a 0, so it is an output pin. Similarly, I have my PIR getting input to the Arduino, so it is an input pin. Similarly, the LDR value is also fed into the Arduino, so again it is an input pin over here. Next, I'm coming into my particular loop. This particular loop is where all my executions take place, and these take place again and again forever, infinity. Okay, so I have to carefully declare what is to be done over here. So first thing, I'm going to check whether there is movement in my PIR sensor. So this is a digital pin that is being connected over here. So I'm digital reading this particular value of my input PIR. What is my input PIR? The one that is connected to pin number 2. So whatever is connected to pin number 2, I'm reading it and I'm storing it in a variable called PIR val, which I have declared it over here. Next, I'm going to analog read the sensor LDR. This is connected to A0, which is the analog pin over here. So I'm going to give analog read over here instead of the digital read. And the particular pin is called the sensor LDR over here, A0. So I'm reading that particular value and I'm storing it in this particular variable over here. And if this result sensor value is less than 600, that means it is night time. Okay, so that you can see it from this particular serial monitor over here when you move this particular LDR sensor. If it is less than a particular value, what should I do? When it is less than a particular value, it will come into this condition. Else, if it is greater than 600, it will come and execute this condition. So if this result sensor value is in the night time, that is towards the left extreme corner, less than the 600, what will happen is it will now check the PIR sensor value. PIR sensor value now, if the value is equivalent to 1, that means if there is a movement over there, if it is equivalent to high, what will happen? I'm digital writing the relay value, that is pin number 13. Relay value, you know, it is the output, which is pin number 13. I will put it to 1, which means the 13 is 1 over here, means the bulb is going to glow over there. So when the bulb is glowing over there, it will be on for 5 seconds until the movement stops. Okay, so if you keep on moving over there, it doesn't mean that it will stop in 5 seconds. When the movement stops, it stop in 5 seconds. Else, if the PIR value is low, if this PIR value is low and it is night time, what will happen over here? It is understood that the bulb should be off over here. After that, what is going to happen? If this result sensor value is greater than 600, that means if light is falling, it is equivalent to daytime. So during the daytime, bulb is not required over there. So during the daytime, what should happen? During the daytime, if it is greater than that particular value, my relay value by default is going to be low here. So that low value is what that bulb value is going to be always low here. It is going to be off. That is what I've declared in this particular line over here. Similarly, all these values that I've got from this LDR sensor is being printed in my serial monitor. So serial print ln, every next line I'm going to print it over here. So you can check into this particular LDR value, which I'm going to be showing it to you now. It is now 874 over here. So now you can move it to different extremes. Okay, so you can move it to different extremes over here and you can see the value changing accordingly. So that value changes is what you're going to be noting over here, and you can check it with the PIR motion sensor value. So you can check it with the PIR motion sensor value over here, and you can see that your bulb is glowing over here. So if it is less than the 600 value over here, that is when this PIR motion sensor is going to that is when this PIR sensor is actually working, and that is when it is enabling this particular relay over here. So I hope you are able to understand the working principle of this particular street light principle using relay.